Electrochemistry and Thermodynamics Experiment, Group 8. A molar solution of the following elements was calculated by means of the periodic table. Here one can see how much mass was required to create the 50 ml molar solutions. Gloves and safety wear were utilized during the whole experiment. To create the molar solutions mentioned earlier, the required amounts of each substance was measured in a labeled beaker using electronic scales. By means of a volumetric pipette, 50 ml of distilled water was collected. This was then put into each beaker to create the 50 ml molar solution. The same procedure was repeated for each solution, ensuring maximum accuracy when placing and measuring the substances. The solutions were stirred mechanically by means of a mechanical stirrer, where a magnetic bar is placed in the beaker, and underneath is a rotating magnet which creates the stirring motion. The beakers are seen placed in a water bath to ensure uniform temperature throughout and to keep it at 25 degrees Celsius in the first experiment, whereas it was varying at steps of 5 degrees Celsius in the second experiment. A salt bridge made up of 2 filter papers dipped in potassium nitrite solution were made up. This was done so that electrons keep flowing and avoid polarization. The salt bridge is inserted in both beakers for this flow of electrons to occur. Here, the electrodes are being cleaned using a mirror paper to remove any oxidization and impurities from the surface to make sure that there is no barrier present to slow down the reaction. This was then rinsed. We tested out a different mixture, so we tried out aluminium sulfate hexadecahydrate and using an aluminium electrode. To measure out the potential difference, the electrodes were placed in their respective solutions and connected to a multimeter set on voltage. By means of crocodile clips, a negative reading was sometimes obtained, indicated that the electrons were flowing in the opposite direction.